Okay, so this is a number 3 of week 10, assigning the oxidation number. The question is, assign the oxidation number of the element in the following. And as you can see here, there are two atoms being combined, and one must be cation, the other must be the anion here. And it is customary to put the cation in the front and anion at the end, and that's how the way that people write those kind of the species whose oxidation numbers are being assigned. So what we need to do is you need to look up your periodic table, and then this is a periodic table. And as you probably remember from my previous discussion, you need to have certain kind of the blocks, right? So this is a S block. This is an S block. This is a D block. This is a P block, right? And one of the important column is this is noble gas columns, and so on. And so what's the atom's tendency is they want to be like noble gas electron configuration. So this is something that they want to achieve as by ionizing, which is a losing electron or acquiring the electron from the others. So let's look at the first example here, which is a lead sulfide. So sulfide is right here, and lead is right there. So as far as the sulfur is concerned, they like to be S2 minus. One state 2, S2 minus, this lead can lose 2 electrons to become like this state, which is became Pb2 plus, and that's a win-win situation because they acquire 2 electrons, become S2 minus. So that's oxidation number. So this is the Pb2 plus. Okay, and then the oxidation number for Pb. Pb is plus 2, and sulfur will be minus 2 when they upon forming those compound here. Okay, so let's move on to the second problem, which is, let me use a purple. So the chlorine, there are 4, and so chlorine itself would like to be chlorine minus, right? So chlorine minus, that's their tendency. And titanium, which is located here, probably they would like to lose 2 electrons, and like this, and then they like to lose 2 more, right? So they like to be titanium 4 plus, became the noble gas configuration. So this is a titanium 4 plus, and then the chlorine, there are 4 of them. Okay, so this is how they are balanced now. So oxidation number wise, oxidation number for titanium here is plus 4, chlorine is minus 1. Okay, so now go to the third one, which is a cesium oxide. So this is getting a little bit more complicated here. So let's look at where the cesiums are. Cesium is located right here, and an oxygen is here. So at the first sight, when you're looking at the numbers, it looks like, okay, so cesium will be cesium 2 plus. And oxygen probably like to get 2 electrons, became oxygen 2 minus. This is probably most normal one. But there is some contradiction because this one likes to be plus 1, and this one is minus 2, so minus 2 times 2, it doesn't match. So something has to give up over the others. And then this is a rule is the cesium wins the one, forcing the other oxidation numbers to be oxygen has a different oxidation number. So cesium can only have an oxidation number of either 0 or plus 1. So those are the possible. Because of that, oxidation number here, the cesium will be retaining as a plus 1. By having plus 1, this one should be minus 1 for two oxygens. So therefore, oxygen will have minus half oxidation number. So that's something that is unusual for the case of the cesium oxide cases. Okay, so that's an oxidation number. So now the O2F2, and so this is must be now oxygen has a positive and this is a negative. So the fluorine, which you can see, let me see, we can use something like pink. Okay, so the fluorine likes to be fluorine minus, and I think that's going to be fluorine minus, whereas oxygen now has to be plus. So I mean, it doesn't, so therefore this one wins, and this side make it minus 2, forcing the O2 to oxygen, their oxidation number has been compensating to the plus 2. So therefore oxidation number for oxygen here is plus 1. Okay, so the answer here is oxidation number is for oxygen here is plus 1, fluorine here is minus 1. So these are the two examples that is more challenging. When there's a mismatch, then the one that has a priority here is something that is not oxygen, and oxygen can have a different oxidation number. So that's what the answer for this oxidation number problem.